Okay, guys, we're looking at section 5.5, part 2. Listen up. We're going to be taking derivatives and integrals for bases other than e. We've taken derivatives when we have a base of e. Remember how easy it was to, when we have the derivative with respect to e, what was that derivative? E to the u times u prime, right? So that's how we took the derivative when our base was e of an exponential function. But what if our base is a? That means anything but e. So our base could be 10, our base could be 3, 4, 2, 5, whatever. If we have a base other than e, we have to use this formula. It's natural log of a times a to the u times the derivative of u. But look how similar it is. See how this derivative was e to the u, and this is now base to the u, and our base is going to be something different, times u prime. So the only thing new is this natural log of a. What if we used this formula for this? Well, it would be the natural log of e times e to the u times u prime. What is the natural log of e? Just 1. The natural log of e, another name for that, is just 1. So see how we get our formula that we actually use? So we could use this formula over here as well, but it's not necessary. So this is going to be new. If our base is 3, it would go natural log of 3 times 3 to the x. That would be our derivative. All right, what if we have log base a of u? Well, we've done the derivative of natural log of x. What was the derivative of natural log of x? 1 over x. Remember that derivative? Okay. Well, this derivative of log base a of u is now going to be 1 over the natural log of a times 1 over u times u prime. So it's very similar. Okay, it's just now we have to add this in. This right here is new. But the rest of it's stuff we've already done. 1 over u times u prime. Over here, if we have to integrate a to the u, it's going to be 1 over the natural log of a times a to the u plus c. When we do integration, we might need to use a u substitution. So we're going to have to watch for that. All right, we're taking the derivative. We're going to use our formula over there on the board and up above. So in this case, a is our base. A is 3. U is our exponent. It's negative x. And so now we're going to take the derivative. So this derivative then is going to be the natural log of a times a to the u times u prime. What is u prime? What's the derivative of negative x? Negative 1. And so this is what we get for our derivative. If you look in the back of the book, they would probably have this answer though. See how that's equivalent? We have natural log of 3 times negative 1. That's negative natural log of 3. We have 3 to the negative x. That would be 3 to the positive x if I take it to the bottom. Okay? Questions there. That's a derivative. All right, well now we're going to take the derivative over here. It's very similar. Now instead of using a variable of x though, we're using a variable of u. Doesn't change anything. But look at how we have a u here and a u here. When that happens, when I have something with a u times something with a u, we have to use the product rule. F prime g plus f g prime. Right here, this is going to be f. This part is g. So we're going to have to apply that product rule to it. So to find h prime of u, the derivative of f, well, this is an exponential function. So I have to use this formula right here. So it's going to be, look at what a is. A is 3, u is negative u. So I'm going to have to do the natural log of my base, 3, times a to the u, which is 3 to the negative u, times What's the derivative of negative u? Negative 1. So that's my f prime. I have to do times g. So times sine of pi u. Plus, now I have to write down what f is. And I have to do times the derivative of g. What's the derivative of sine pi u? Cosine pi u times what? Pi. Now this looks very confusing. But you have to realize that this is all multiplication plus, and then this is all multiplication. So all we really have are two terms. We have this term and we have this term. Just two terms. Simplifying this one, I've got a negative natural log of 3 times sine pi u. This is a 3 to the negative u. What should I do to make that exponent positive? Take it to the bottom. So it's over 3 to the positive u. Plus, looking at this next term, I've got a pi and a cosine pi u. And then I've got this. Well, this can go to the bottom if I make it a positive exponent. This one, I should just kind of put it together. Pi cosine pi u all over. This goes to the bottom. Do I have a common denominator so I can just write it as one value? I do. What our book would probably do, since this is a positive term and this is a negative term, they'd probably write it like this. Pi cosine pi u minus the natural log of 3 sine pi u all over 3 to the u. So all of that just simplifies down to this. And a lot of times we're okay getting this first step, but then seeing why it's equivalent to this, that's the difficult part. Equivalency is a big thing to understand, especially at the college level, like just understanding like the simplifying with the algebra. That's actually even more important than the calculus part, really. Okay. What about number 3? This is log base 6 of 3x. Do we have a formula to find this derivative? Right here. See it? The derivative of log base a of u. Match it up. What's a in this case? 6. What's u? 3x. So finding this derivative, here's what we've got. So it's going to go 1 over the natural log of 6 times 1 over u times du dx. What's the derivative of u with respect to x? What's the derivative of 3x? 3. So this is what we get. This is all just multiplication, so we're just simplifying. So we've got 3 divided by 3, that can cancel. And so we probably would just want to write this as, this isn't the natural log of 6x, it's really the natural log of 6 times x. So I might want to just put this x first. That makes it easier to understand what's going on there. All right, the next one is another log problem. If I can, I should probably rewrite this in a different way. See, right now I've got y equals log base 3 of x squared plus 1 to the 1/2. What could we do with that 1/2? Bring it out front, can't we? So I can think of this as 1/2 log base 3 of x squared plus 1. That will save me from having to use the chain rule so much. So now finding our derivative. Well, to find the derivative of this now, I can just bring down the 1/2. I look at my formula. It's log base 3 of this So looking at the formula for the derivative of log, it's going to go 1 over the natural log of our base, which is 3, times 1 over u, which 1 over, there's u, times, and then what's the derivative of the u? 2x. Can anything simplify there? The 2's can cancel, it's all multiplication. So in the numerator now, all we have is an x. In the denominator, we might want to put the x squared plus 1 first, and then natural log of 3. So what we did again was, once we rewrote it to the 1/2, bring that 1/2 out in front. Then you won't have to use the chain rule. Well, you did a little bit, but not as extensively as you would if you had not done that. All right, last thing, this is integration now. Remember here at the end, we're putting it all together, which is what makes it difficult, derivatives and integration at the same time. So looking at our formula for the integral of a to the u, it's 1 over natural log of a to the u plus c. So we need to identify what's going to be our a in this case. What's our base? 3. Our u is going to just be x. I don't need to do a u sub if u is just x. All right, so I'm just going to follow the formula. So looking at the formula, it's 1 over the natural log of a times a to the u, which is x. And now this is a definite integral, so we're just going to plug in our numbers of 4 and 0. So plug in your 4. 3 to the 4th over the natural log of 3 minus, plug in your 0, 3 to the 0 over the natural log of 3. What is 3 to the 4th? 81. How'd you get that? You just kept multiplying? A lot of things though, like when people are doing 3 to the 4th, a lot of people go like this. 3 times 3 is 9, times 3 is 27, times 3 is 81. But a lot of you don't know 27 times 3 is 81. So just think of it like this. 3 to the 4th is just 9 times 9, 81. That's easier. So we have 81 minus 1 over natural log of 3. And that's going to be 80 natural over natural log of 3. Remember, those definite integrals are things that I can check. If I wanted to check this, I can go on my calculator, put in 3 to the x. I'm now going to see what is 80 divided by the natural log of 3. There's what that is. And now I'm going to go to my y equals. I'm going to do a zoom 6, graph it. And I want to know second trace, calculate that integral from 0 to 4, and look what it tells me. That answer is 72.82. Well, look what I got on the other thing, 72.82. See how I can check it? All right, this one is the toughest one on here. Here's why. I can't split it apart, so I have to do a u sub. I have to let u equal something that's equal to the rest of the problem. If I let u just equal 3x, that's just going to give me a 3 dx. I have to get rid of a 5, 3 to the x, 5 to the 3x. So I'm going to have to let u equal 1 plus 5 to the 3x. I have to let u equal that whole denominator. That derivative, what's the derivative of 1? 0. The derivative of a to the u, look at your formula right here. The derivative of a to the u is going to be the natural log of a times a to the u times, what's the derivative of u? What's the derivative of 3x? 3 dx. So all of that's what we get for our derivative. Look at it. Right here. That's our u. That's good. But we also have to look at that numerator. Here's our numerator. We need to get rid of that. 5 to the 3x dx. Look what I've got for my derivative. 5 to the 3x dx. But what do I need to get rid of? Right, so I have to divide by 3 natural log of 5. So that 5 to the 3x dx, this 5 to the 3x dx, is going to get replaced with 1 over 3 natural log of 5 du. What am I left with now then? I know what we'd be left with? Good. We would now have 1 over u. Do you remember the integral of 1 over u? What is it? If you don't remember, it's on your green sheet, but I was hoping you'd remember. Right. It's the natural log. Look, guys. Look here at number 11. The integral of 1 over u du is the natural log of the absolute value of u. We would just look that up on our green sheet if we needed to. So this is going to be then 1 over 3 natural log of 5. This integral is going to be the natural log of u plus c. I need to look back and see what u is. So it's going to be the natural log of 1 plus 5 to the 3x, that was my u. Watch how I do this. Over the natural log of 125. Anybody know where that came from? How did I change 3 natural log 5 and a natural log of 125? Yeah, that can become an exponent, so it's 5 cubed. Also, why didn't I use absolute value here? Don't we have to use absolute value? Yeah, this would always be positive, wouldn't it? 1 plus 5 to the 3x, that's always a positive value. Exponentials with that positive exponent are always going to be positive. So there's our answer. All right, so this is more difficult than probably anything we've done, but it's a good thing to end with. You've got to go back and forth between derivatives and integrals. It's just a matter of plugging into formulas, and that's an important skill to have, to be able to plug in and be exact and not drop numbers and things like that. Right. Okay, so you've got your assignment up here, page 357.